Yeah, good morning. Myself, Dr. T.S. Srinivas, working as Associate Professor in Department of CSC. Today, I'm going to discuss about the introduction to the relational model. So, the course outcomes of the relational model is we are going to understand the concept of DBMS and evaluate the database models and apply the architecture to the DBMS and design the database using the ER models. Apart from this, we are going to understand how we are going to define the relational model, and also we are going to define what are the different data items that are present in the relational model and different integrity constraints that are used in the relational model and how we are going to enforce the integrity constraints. So these are the syllabus of the unit 2, which is the introduction of relational model, integrity constraints over the relations, enforcing integrity constraints. This is the most important topic, and querying relational data and logical databases design, and introduction to views. This is the most important topic, and destroying and altering the views, table views, relational algebra, tuple relational calculus, and domain relational calculus. So the relational algebra here we are going to, in this unit we are going to discuss. So in the relational algebra, there are two types of algebra. One is the tuple relational, and other one is the domain relational algebra. So what is relational model? It was introduced in 1970 by Edgar F. Codd. So what he said is he has organized the data into the relations. So here for any relation, so the relation is nothing but it is there are two entities. Between the two entities, we are having the relation. So one is a student entity, another one is a course entity. So in between student and course entity, we are having a relation. So student registers for the course. So when students are registering for the course, this is called as a relation. This is called as a relation between the two entities. So entities are described with a rectangle, and relation is described with a diamond symbol. So here the data is arranged in the tables with rows and columns. So this is example of rows and columns. Student ID, student name, age and department. 101, 102, 103 are the student IDs. And names are Asha, Rahul and Priya, and age is 20, 21 and 18. CSC department, EC department, and again CSC department. So here you can see that data is arranged in the form of rows. Rows, we are defining the data items. So student ID, we also call these data items as the attributes. As I told in ER diagram, in my previous slide, in my previous ICT presentation, these are the data items. We also call them as the attributes. So for each attribute, we are having the data items. So these are the different data items for each attribute. So we are having 4 attributes, and for each attribute, we are having three data items. So what is the basic concepts of the relational model? So basic concept of the relation model is a relation. Relation is nothing but here, as I told, it is a table where we are going to store the data. Second one is the attributes which describe the properties of the data, like student ID, student name, student age and email ID. So what is tuple here? So represents the individual records. So you see here, this is a tuple. So in the tuple, we are having the information about the student ID, student name, age and department. So that is nothing but it is a tuple. So we will define the tuple as, tuple here we will define as student ID, student name, age and department. So we will write like this: student ID 101, Asha, 20 years, and CSC department, comma. So each record is separated with a comma. Next 102 and Rahul, 21 and EC department. So next tuple 103. So the record, tuple is nothing but it is a record. So how the record is formed? Record is formed with the student ID, student name, age and department. That one record which you enter in the rows, that will become a tuple. So in DBMS, the tuple is a concept where we enter the data in the form of rows and columns. So here we can represent individual record. Record is nothing but complete row information. So that row information consists of student ID, name, age and department. So what are the components of the relational model? The relational model, these are the different components. One is a relation, which is nothing but table name. Other one is a tuple, which is a row, that is nothing but it is a record. Attribute, column. So what are the in the column what are the data you are going to enter? So here the data we are going to enter is 101, 102, 103 for student ID, Asha, Rahul and Priya for name, 20, 21, 19 that information for age, CSC, EC and CSC that information for department, attribute. Okay. So tuple is a row, attribute, column, domain, set of values, valid values. So here you can see, now I have defined 101. 101 is the valid values for student ID. So when you are going to create this particular table, or which is nothing but relation, we have to give the student ID data type as the number. We have to give student ID as number, student name as character, student age again as number, student department we have to give the data type as the characters. So the domain is set of valid values. So when you are going to define a number, we are going to give insert that in that particular column, insert in that particular column only the numbers. When you are given character, insert in that particular column only the characters. When you are given the department, insert in that particular department column only the characters. So whichever way you are going to give the values, in that way you are going to define the data. Next is degree. Degree is number of attributes. So what is the degree of this particular relational model? We are having 4 attributes, which are student ID, name, age and department. So the degree is 4. So cardinality. Cardinality means it defines a number of tuples. So how many tuples are there here in this particular table? We are having tuple. This is one tuple. This is one tuple. This is another tuple. And this is another tuple. So in total we are having 3 tuples. So that information we are going to define in the cardinality. So now in that particular relation, we are having some important concepts which are called as the primary key. So what is a primary key? Primary key is nothing but it uniquely identifies each record. So here in this table, if I define student ID as the primary key, 101, 102, 103, 3 are different numbers. So any primary key which you define in the table, that particular primary key should have an atomic value. So what is the meaning of atomic values here? Separate values. So 101 student name is Asha. 102 student name also you can have Asha. But 101 cannot be repeated because we are defining student ID as a unique. Unique means which is having only one value. So 103 I can write Priya. 104 I can also write Priya. So initials are different. So age may be different. So this student ID, so here what I want to say is, if you are going to define student ID as the primary key, then what happens is it should have separate numbers 101, 102, 103. Now 101 name is Asha, 102 name also I can have Asha, because 101 and 102 we have defined as a primary key. Names can be same, but IDs will not be same, right? So this Asha which we are talking, they are different people, because 2 people cannot have the same ID. So here 101 is a student ID of a Asha, of a student name Asha. 102 is a student ID of name Asha. These 2 names are different because we are having 2 different IDs. Age can be one age can be same, no problem. Department, one is CSC, other one is EC. So both departments are different. So we can have information like this. So the first one is uniquely identifies each record, that is called as a primary key. So what is foreign key? So suppose in foreign key we are having two tables. In one table I am having student ID as a primary key. In another table I should have the same student ID but not as a primary key. So here I will take one example. In student table I am having student ID, name, age and department. Here I am taking one more table which is called as a course. Here course ID is a primary key of that particular table. Course name, C name and student ID, SID. So in one table SID is the primary key, in another table SID is the foreign key. So why we are going to use the foreign key? Because this is going to connect the two tables. If we are having same attribute present in one table and the same attribute present in one table as the primary key and the same attribute present in another table as the foreign key, so there will be a connection between the student and course table. How the connection is done? The connection is done through the foreign key. Next one is the candidate key. It can uniquely identify a record. So in the student table, I can have a foreign key like this, student ID, comma, age. In the same table we are going to define, not in another table. So in student table, I can have a combination of the candidate keys. That means compulsorily one key should be a primary key and other should be attribute of the same table. Which table I am talking here? The student table. So student ID and age, I can have one candidate key. I can have student ID and department as another candidate key. I can have student ID and age as another candidate key. This is called as the candidate key. Next one is the composite key. Composite key means it's a combination of the two different attributes present in the table. So in the composite key, in the candidate key, one of the key should be a primary key, but in composite key, that is a difference. In composite key, I can have a attribute, I can have a key like this, name and age, student ID and name. So this will become a candidate key. And also it will become a composite key. So this is a composite key. Why? Because there is no primary key. So here if primary key is also added, then it becomes a candidate key. If primary key is not added, then it becomes a composite key. That is the difference we can have. So one more composite key we can have. One is age, other one is department. We can have a composite key like that. So it is a combination of two or more attributes of the same table. So that is called as a composite key. So here you can see example of the primary keys 101, 102, Asha and Rahul. And here C101, 102, 101, 102. C101 is nothing but it is a foreign key of the other table, which is a course table. And 101, 102, these are nothing but it is a primary key of the student table. So this is a primary key of, this is the course table where we are having C101 course, 102 course, 101 and 102 both are the primary keys of the student table and these are the course names. So this is a combination of the foreign key. Foreign key means one of the keys should be a primary key of the another table. So these two are the primary keys of the student table. And these are the primary keys of the course table. These are the primary keys of the course table. So there is a link between the course table and the student table. So when you are having a data like this, which is a primary key and also the primary key of the another table, that two are clubbed and it is going to form a table in this format. So this is the example for the primary key and the foreign key, and this is an example for candidate key and the composite key. So in the candidate key, compulsorily we should have a primary key and one of the attributes of that particular table, and composite key we need not have the primary key, we can have a combination of two attributes without a primary key. So that is a composite key. Now what are the different features of the relational model? The features of the relational model is, first one is the data is stored in the tables in the form of first rows is there where you are going to enter the attributes, and in the columns we are going to enter the record. How we are going to store the data in the form of tuples. So first we will enter the student ID, then we enter the name, then we enter the age, then we enter the department. After completing all this information, next we will enter again the student ID, name, age and department. So we can enter as many records as possible in this particular relation. So here the relation means the data is stored in the tables. Now each table has a unique name. Yes, definitely. So as we have seen here, this is a table, course table. It is a unique table because it is having the information about the course. Here student table is there. Here too student table is there. Student table is having information only about the student. So each table is unique. Each table is unique. So there are no duplicate rows. So any duplicate rows are there. So C101 is separate, 101 is separate, DBMS is separate, C102 is separate. So we are not having any duplicate rows. So if any duplicate rows is there, your DBMS will not allow that particular row to be created, because it will say that already we are having a record with that particular course ID or with that particular student ID. So there is no duplicate records, and definitely it is very easy to retrieve the data. Why it is definitely very easy to retrieve the data? Because here there are no duplicate rows, duplicate rows are not present, and we can retrieve the data by using the IDs of that particular we can retrieve the data using the IDs, or we call it as the primary key of that particular table. Now we are going to maintain the data integrity. Yes, definitely, because there is no inconsistency of the data. The data is consistent, so we are going to maintain the integrity of the data. And definitely there will be a relationship between the two tables by maintaining the keys. Two keys are there. So with the two keys we are going to maintain the relationship. So in this way we can understand the concept of the relational model. And what are the advantages of the relational model? We can easily understand. We can easily maintain the relationship. The data consistency will be there, and the data retrieval will be very fast because there are no duplicate records are present. Data integrity can be maintained. So there will be a security of the data will be more, because you are going to maintain different records, because we are having a concept of primary keys and foreign keys. So because of that concept we can maintain the data, and the data is more secure and it is easily maintainable. So disadvantages is definitely when you are having a large database. Now when you are having a large database, the maintenance of the relationship will become a complex. So in the relationships, in this model we are going to have a one-to-one relation, one-to-many relation, many-to-one relation, and many-to-many relation. So when I am going to work with one table, it is one-to-one relation. When I am going to work with two tables or more than two tables, it is one-to-many or many-to-one. Many-to-one, one-to-one, one-to-one, one-to-many, many-to-one relationships can be, these three relationships can be easily maintained in the case of the relational model. Because the retrieval of the data, definitely when you are retrieving the data, it is mandatory that the primary key of the one table should be a foreign key of the another table. Like that, you can access any number of tables, provided you are maintaining that condition. But when it is a large database, then the database design is very complex, because you are going to have large number of joins. The conditional statements are more. By maintaining the conditional, by giving more conditional statements, definitely the performance of the performance of the relational model decreases. That is the meaning of these statements. Very large database means when you are having more number of relations, that is the tables, then definitely the performance will increase. Complex joins can be slow. Yes, definitely, because when you are having a large database, there are many tables. So many join conditions you are going to give. So when you are going to give many join conditions, what happens is definitely the joint conditions are complex, and you have to give correctly, we have to give the statements. If not, it will give a different result. So this particular type of databases where you are having a relational model with large database, definitely it requires a proper database design. So when it then the schema changes may be difficult. So what is schema here? Schema is nothing but it is a logical definition of the database. So you can refer to my previous ICT presentation where we have defined the difference between instance and schema. So in that I defined the schema is a logical design of the database. So in for example, one small example I will give. Logical, why it is difficult. In one table I have given the phone, in one table I have given the student ID as character. Student ID as varchar, student ID as varchar. In another table I have given the student ID as only the numbers. So when we are linking these two tables, so varchar means I am having a combination like this, 257y 1a0, like that I am having. When I am defining it as a number, so 506 number, when I am defining it as a number 506, this is varchar, this is number. So when I am linking, when I am giving a joint condition, one is varchar and another one is a number. So that becomes a complex. So the data cannot be retrieved if we are going to have this type of data types. So in that case, the schema definition changes may be difficult. So that is the meaning of the schema changes may be different. So where we can apply this concept of relational model? Definitely in each and every application of the database systems, we can apply the concept of the relational models. First is a banking system. So in the banking system, we are having different relations. One is customer relation, other one is savings account, other one is finance account, other one is account department. So there are different entities in that particular relation. So when you are having different entities, definitely we are going to use the relational models. And hospital management, yes, in the hospital we are having different departments. So one doctor from each department will visit all the departments. So in that case, when he is performing the surgery, in that case he is going to link up with all the departments. Right? So there we can apply the relational model. In the library management, so in the library we are having different department books, CSE, mechanical, civil, electrical, computer science, AIML, data science, different departments we are having, we are linking up with different departments. So definitely we are going to maintain the relational model. And next is student information system. Here also different departments are having different students. So there we will maintain the records. And e-commerce applications, you are booking a product. When you are booking a product, you are having this information. So the products are of different types, and inventory management. So finally, I would like to summarize the relational model like in the relational model, data is stored in tables. We are having rows and columns, and we are having a concept of keys, and we are using the SQL statement to retrieve and manage the data. And it is this relational model is widely used in the database today. So thank you.